Okay, let's begin this stream and the video. Welcome back to the Twitch stream. Welcome back to the video series on YouTube. We really appreciate you checking us out and hanging with us for so long, especially if you've made it this far into the video series without rage quitting and throwing your hands up in the air and saying this guy's a complete idiot and he should just shut his channel down. Hey, I really appreciate you sticking with me and sticking with us for this adventure. I know it's helter-skelter, but, you know, that's who I am. My mind always bounces between multiple different things and always kind of moving in a weird, fast pace, but, you know, that's how things go sometimes. If you like what you're seeing, you like what we're doing, definitely like and subscribe. Hit that bell notification to be informed of when we drop new videos on YouTube. We really appreciate it. It's crazy, but we're shooting to get 1 million subscribers by the end of this year. Come on, we can do it. Let's just mess with the algorithm and just make that happen. There's no reason not to. Let's just be crazy about it. Let's throw everything for a loop. So yesterday, not yesterday, but the previous video, might be yesterday to some viewers out there, depending on how you're catching my videos on YouTube. We were doing the board testing and ran into a problem with the stepper motor driver. The stepper motor would not operate, so we're kind of troubleshooting that. And I think it might be me being a goofball and making a mistake and not paying attention to the operating logic of it. So I'm hoping that's all it is, because I've looked into the ESP32, the lead C PWM is supposed to work on all outputs, just not the input only pins. So I can route it to any pin. So that shouldn't be a restrictor. So I pulled up the data sheet for the driver, and I'm hoping this is it. I can't guarantee it. So I pulled up the data sheet and highlighted the reset pin. So I have to make sure it's high. And then the biggest thing right here is the enable. Logic high actually disables the device. I need to set it to logic low. So I think I made a mistake. So I got to make sure that the reset is high and then the enable pin is low. So let's go with our stepper test. So we have to set this to active low. And I've kind of put this back in low speed mode. That's where I've had the most success. Because of this, the testing I've done with just operating a basic conveyor for like SMT, not want to push it too fast because it doesn't need to move that fast. So I'm just kind of like leaving everything the way it is now. So let's get this compiled and then pushed over, and we'll see if the stepper motor operates. And if the stepper motor operates, we'll switch it back to the one I wanted on there with the timing belt gear. For one thing, it's got longer leads. This thing got such short leads, and then also it's got the gear already attached to it, the timing belt gear, drive gear. So I just want to use that one instead. And the longer leads definitely makes it a lot better. So let's push this over and let's see. Okay. Is it trying to do anything? Okay, well, the stepper motor is actually locked. So, all right. So there's a good chance. Okay, let's see if I can go over to the webcam. Okay. All right, we're live. Okay. This is kind of good. I don't know why the status LED is trying to put something out unless I've got the wrong pin, but I don't think so. So I've got the KiCad. Am I upside down? Yes, I am. Hold on, let me fix that. My goofy, it looked right. All right. All right. Hey, you know what? Eventually I'll get my act together and everything will work right. And um, I'll be among some of the greatest YouTubers ever. No, that'll never happen. All right. So, for some reason, the status LED's on. Might be the LED doesn't. Or the pin that's on is shared. It could just be an anomaly with how things work. Let me make sure I'm not sharing that pin with anything. I shouldn't be because schematically everything's fine. IO4 is by itself. There's nothing else tied to it. So it could just be since it's in an undeterminate state, the system doesn't know exactly what to do with it. So one of two things is possible. My duty cycle is out of whack, so I'm going to drop the duty cycle. I'll build it and re-upload. Because right now all we care about is getting rotation. Is getting the stepper motor to actually turn. I don't care about direction. I don't care about speed. We are just ensuring that this driver chip works. So let's flash this guy over and see what happens. Well, we've got a whine out of it, and that is actually a positive. Yeah, I'm making sure the main chip isn't overheating at all. So either one, let's try changing the duty cycle. Or I've got something borked with the wiring, and I've got to double check on my wiring. Because I could have a couple wires reversed, and that's very possible. Whining is good. That means it's trying to drive it. Okay, so it's trying to drive it. Like I said, that's a good positive. Disable my power supply. So there's a chance I got the B outputs reversed. Just gonna kind of pull up the order on these real quick. And renewal. Okay. Still whining. So again, now this motor could be problematic. Let's put the other motor back in here. Just for giggles and grins. Because I know this one works too. I've used it on other things. I tested it on another project. So I need to double check my schematics because I could have some silkscreen labeled wrong, and that's perfectly fine. It's something we can correct. Okay, so again, could be the duty cycle, the micro stepping. All right. Let's kick up the duty cycle. But this is a good sign. This is a very positive sign. Because it's trying to drive the motor. Okay. Okay. That's good. That's good. So I could have the red and the green backwards. Nope. Red and green are not backwards. And turn you off. All right. Maybe didn't like the fact that I tried hot swapping these. Never really played around with that. I think it'll throw it into a fault condition, since we're not really monitoring that, which is kind of good. Come on, you little guy. I'm actually hoping it's just something dumb. All right. So, let me go and... Okay, so we know it's trying, so let's rule out complete wiring errors. All right. All right. Let's go here. Let me find my notepad, the one with the separate motor. All right. So red and green are definitely one of the coils. Red and green are one of the coils. Yellow and blue are the other coils. So red and green. So let's go back to the schematic. Go to the stepper. Yeah. Okay. Okay. I think I know what I did wrong. I will have to invert some stuff, I think. 5, 7, 8. Yep. Oh. Pin 5, A out. Should be here. 1 and 2 should be B out. Okay. So red and green. Need to rule out a wiring mistake. Just need to rule this out. Okay. Then yellow. Well, then blue should be here because this would be number 2. And this would be all right. All right. So all right. So we've got it wired up the way it looks like it should be wired up. Still just sitting there humming, so it could also be micro-stepping mode. They should all be low. So it should be a full but let's see here. Let's go back to the schematic. And I'm going to set... We're going to play around with the micro-stepping modes and change their values. Your step, let's see here. Step preset. Step enable. Step direction. Micro-step 0. We're going to set it to high. Now, idealistically, I should have this set up to where I could use a FTDI, the serial interface, to talk to it. But again, this is supposed to be just a bench test for this level of the board. Let's see if the micro-step mode is wrong. 1. Definitely getting changes, which means it's trying to drive. that sounds so horrible. Oh, yeah, all right. All right. Because again, I copied this off of another project, these settings for the duty cycle and everything. Let's just deal with that horrible, horrible sound. Oh, that's even worse. Oh, 1, 1, 1. And then we might have to play around the duty cycle. Wait a minute. There we go. Boom. All right. So again, all right. So the micro stepping mode, we had to, with my current settings on this. All right. So the whole problem was a me issue all along, and that's the way it works. I accept that. So let me go back to the data sheet real quick. So let me go to the chart for our micro stepping modes. So one of the biggest lessons to learn is data sheets are your best friends. They will teach you and help you the most when you run into problems. They will help you find where you make mistakes. So all 3 modes are being pulled high. And so it's basically 32 microsteps per step. Again, I pulled this from another project that I've been working on. So it's configuring itself for, it was just basically to run a SMT type conveyor, which does not have to run that fast to run a board from one machine to the other. You can definitely tell we got rotation, so we're counterclockwise. So let's set the direction to 1. So then it should rotate clockwise. Once it builds and I flash. Again, idealistically, we'd have all this controllable via RS-45 or a serial console through the FTDI. This is just for testing. There we go. We've got clockwise. So what we could do then is leave that alone. So what we'll do is we'll go back to here to the code and we'll turn this into an actual test. So stepper direction will be 0. Put a note. Counterclockwise. So that's why I drew that line on the top of the, I think one of the things I'll do is 3D print like a little flag, like a red flag, something really visible and easy to notice that it's rotating. For once we get to the point we want to release this, we want to turn this into a release product to have a bench test during the assembly / test phase before it goes into a box to be shipped out to a customer. That way everything can be kind of like in a test jig. Stepper motor already been there. You just make all your connections with your pluggables and do your bench testing and everything will work. So that's what this, we'll do a better test plan after that. So, okay. So what we need to do then is here in the while loop, so what that does, it's going to operate. We're going to level. I don't know why you just copy and paste. We're going to basically we're going to invert the logic here to basically shut it down. Give it like 50 milliseconds or something like that. Internal system. Internal system. Then we're going to set okay. Just copy and paste this, because then set stepper direction. Direction by default up here, since this is the second one, it's 0, so we're going to set it to high. Set direction to direction clockwise. All right. All right, then we're going to re-enable. Let's see, re-enable. Wow. Reset. Actually, the proper term is deassert reset. If I spelled it right. If I didn't, I didn't. Now we're going to come up here. Let it run the other way. So and then what this should do is step for direction. We're going to make sure we set this, even though we set it by default, we're going to set it right here. Counterclockwise. Okay. Stepper enable. So, with any luck, what this should do, if my logic is right, which it probably isn't. Go back over there. So what should happen is it should start up, rotate counterclockwise for about a second, shut the system down, switch direction, rotate counterclockwise for a second, and then repeat. Might be too fast. All right. So there we go. So let's give ourselves Let's give ourselves like 10 seconds. The body of the motorcycle. Hey, we've made a little agitator for washing machine. There we go. All right. So I give about 10 seconds each direction. Should have a stopwatch timing it, but there we go. And the cool thing is so we're only pulling around 272 milliamps. I mean, granted, that's not bad. It's not loaded at all. So basically, it's a completely unloaded stepper motor, 270 milliamps. So that's pretty darn good. Now, that's according to what the power supply is saying that it's delivering. But right now, I am happy because now the stepper motor works. And we can check that off of our to-do list. Go here. Honestly, this is like probably one of the biggest things. All right. Well, let's chunk into one of the easier things to go into. PWM fan. All right. So here's something cool. All right. So I don't know why I've got the build directory in there, but that's fine. Let's go into our project folder. And fan test. And get rid of build, get, and paste that into fan test. So then what we're going to do is come here to stepper test. This is all we needed to do. It's the motor is rotating. I'm happy. All right, close that guy out. Let's go over here. Close this guy out. Fan test. I'm going to open this guy up. Open code. Well, that does its thing. We're going to come over here. I'm going to put the motor down, unhook it so it doesn't get annoying. And I'm going to hook the fan up to the fan connector. I'm also going to grab my FTDI and hook it up because we're going to need the serial interface. So there we go. I got that stuff connected. Bring up code over here. Get you out of the way. All right. So we have this. So now we have the fan. I don't have the serial, the UART in here. I'm an idiot. So what I'm going to do is fan test. We're going to add that. Cool thing is, all I have to do is copy this and that. Make sure I'm implementing this right. the way here. Wrong one. Drag this over here. Drag this back. Yeah. All right. So. Okay. So here's some extra coding we're going to be doing. Okay. See, now this one will just do its thing. But let's go through and clean this up and actually make it into something. Fantastic. All right, close this guy out. All right, so under components, we have PWM fan and UART console. So we're going to start here. We're going to drag in. I don't know why I just did that. I could just copy out of here. Show you how some of the stuff is done. All right. Well, so it's going to fan init. So, and then I'm going to grab this stuff out of here. Console and main. We can get rid of that. We probably won't need that because we're going to call this. And we're going to set it at 0. All right. Get rid of this guy. We're going to just kind of change this. Fantastic. There we go. So they'll show up on the UART console. This garbage we won't need. Well, I'll leave it there for now because I don't want to break anything. We'll just make the while loop just irrelevant with the 0. It's false. So I'm going to grab the schematic and drag it to the other screen. That way I can get the signals. So fan tac IO22. Oh no, that's PWM pin. That's 23. TAC pin is 22. Pulse per revolution we'll leave alone. And RX is 19. TX is 21. So then what this will do is it will initialize, it'll send over to, so I've got all this, it'll send over here. So we have some functions that we can call from within a program or even a serial terminal. So let me show you something. So the UART console I put together, you can modify. So what we need to do then is we edit the C file for it, the UART console.c, and then what we're going to do is include I think we can do it that way. PWM fan.h. I think we have to go to PWM fan /, and that should include the fan, the header. The reason is then we can come down here. Now, show this help message, echo, we can leave that command here. So what we'll do is here, we'll copy this guy. A little crazy, a little crazy. Little line here. Let's go back here. Let's get rid of some of these other ones, because I think that'll be good enough. So that's the great thing about this is you can so if you do get fan art, let's see here, fan set. Fan set, let's make sure it's all fan underscore set. Maybe, let me make sure. Fan underscore set. So now we could change it really to be just fan set, all one word, but I'm fine leaving it alone like that. That way I can fan set number to set speed 0 to 100. Control V, and that should be get fan RPM. To get the current fan speed. Now, so we can keep adding more commands. So what we need to do then is you need to copy this. All right, this is where it's going to get crazy. So I kind of like to do this. It's not the cleanest, and I'm sure it's not. Okay. Fan set. What we need to do here is fan set. So then what we need to do is pull the argument, your console argument. I think that's all. So what that should do is that should set the fan. Let's see. We're going to do this. Fan set. About that. All right. So what that should do, if I'm go here. M. I got to remember how to. I think it'll send. I think I can get it to send the number. Oh. What is it? Let's see here. Hold on. It'd probably be easier for me to look up an example of where I've used it because it's been a while since I've done it. Here's a project where I used it. fan.c. It's the console. Wait a minute. Nope, that's not the one I want to look at. All right. Stop switching around on me. Come on. All right, let's see here. Components. Our console. All right, here we go. Actually, what we can do is, actually, it doesn't matter. Fan set. All right. So I think this is what I had to do. All right. 100. Okay, okay. Fan set. Fan get. All right. All right. Can I look at an old example? One of the great thing about modular building, you could use these guys anywhere. So hopefully, let's see if it compiles. Well, that error is probably gonna puke its guts out somewhere along the way. But I'm gonna turn this guy on. In the meantime, the fan's gonna go full blast. So let's see if this guy pukes its guts out. Kind of hoping it doesn't, but I always expect that because I always make mistakes. There we go. Now you're running full bore. And we're going to need COM21. We'll need that. I'll drag that off screen for a minute. Yeah, poor little fan is just full blast. But we're only pulling 70 milliamps according to the power supply, driving that fan at full blast. Mind you, the stepper motor's not attached, but hey. Again, this whole part of the exercise is just to test the fan. That separate subsystem. And we could go through and tweak all these individual tests out, write better logic for them if we really need them. It's not like we have to have them. Clean them up. But the whole point of this testing is to bench test each subsystem. And the main goal is just to get something working. So to be totally fair, I don't really care what they look like because this serves a purpose. There we go. And at the end of the day, what are you complaining about? Oh, you worked. Okay. The slash. Oh, I gotta select the right COM port. Guess that would be helpful. So with any luck, the fan will stop. Perfect. All right. So let's put this guy over here. Okay. I probably have either not enabled or I've got it. Yeah, probably got the FTDI reversed. That's just my luck. Okay. Or I don't have something going on right. Did I bet you like an idiot I reversed my pins? Oh no, there it is. It just took forever. Oh, why is it taking so long to... Oh, that's right, because it's kind of blocking while it does a pulse count. It's so to get the RPM value off the fan, what it does is, let me see here, PWM fan. So right here, so we're using the internal pulse counter off this guy. So let's see here. That's a nit, yeah. So we're actually driving it with a LED sheet channel as well for the PWM. So when we actually go to write official firmware, we'll have to make sure none of this is conflicting, select new LED channels and stuff. But we'll take care of that when the time comes. And then we are, that's the fan init. Get RPM. Okay. The pulse counter. We're using the pulse counter module. So what it does is when we do a fan get, it has to kind of delay. Now we might be able to drop that delay. It depends on how long it takes for it to actually count properly, but this is where I got reliable value, so I'm not going to mess with it. So then it runs all this. This is the map function that you've seen in Arduino. I mean, it's just standard C. I like using it. It just makes life easier. So I don't know if you can hear. So let's go back over to Putty. So fan get, the RPM is 0. Go over back here to the camera. As you can tell, the fan is not rotating. So I'm going to, I won't switch back and forth all the time, but fan set 10. It may not work. Yeah, it's trying. So sometimes they have a voltage threshold. Oh, there it goes. 30%. So now its rotating is approximately 2,520 RPM. Now what I should do real quick, go back over here to Mausa. CFM. So one of the things we want to do, 4010. Don't worry, I'll switch over to the camera. 22. Pull the data sheet for that little guy. So it should have maximum revolution. All right, 4010. 03, the maximum RPM typical is 8,300 RPM. Okay. So let's go switch over to here. So we're at roughly 30%. Yeah, you can't really tell, but I'm going to take my mic off and you can definitely hear it. Yeah, you can't really see the speed. I don't really have a high-speed camera or anything, but with the microphone over here, you should be able to hear it change. I don't even know if you're hearing it. 50%? You still moving. It just sped up. And that's roughly 4,200 RPM, roughly. Perfect. Close. Approximately 60. Cycle. About 76 on the RPM. Oh, look at that little guy go around. So, may not be a full cycle. Grab the mic, put it back up here. Sorry. We'd have to tweak out the settings in the fan driver. But this is another big positive, another big win. So the fan does work. Chop my finger off. Don't want to do that. So the goal, I mean, heck, 100%, that's a lot of power, that thing. There's a lot of air blowing across that thing. So I'm thinking the plastic enclosure or component for this, who knows? It might be more of an open. I don't know. It depends on test points for that. Because under general circumstances, you may not need to be actively cooling that down. So now let's see if we can turn it off. 0 RPM. Boom. Okay. So that is a very big positive and an actual another win for us because that got the fan tested. So far, all of our subsystems are working, and that is big. This is good. So we've got a couple other subsystems that we need to test. Yeah, the LED really loves sitting there glowing. And I think if I would actually give it a definitive status, a definitive level like 0, it would probably turn off and not have to worry about it. This is what I was saying earlier on the series, that LED may just come on because of how pins share and the ESP32 does its thing. So wow, this is a big a good win for us. So the only other subsystems that we need to do, the input tests. So we're going to have to write some firmware around that status LED and the inputs. And then we'll have to probably throw together a PLC routine and tie everything together, which will be interesting and fun. Let's see here. Then the temp sensor. So the easiest thing to test next would probably be the temp sensor. We'll throw together some real quick junk code to test it and get the conversion off the ADC. Figure all that out. I know the ADCs on the ESP32s can be a little bit of a pain in the rear to work with, but we'll work with what we have. So, one of the things we can do is, let's pull up the PCB real quick. Because what we're going to do is, we're going to real quick, the reason I'm pulling this guy up is it's just much easier to find the pins. Where's the temp sense? All right. So it's this guy, 24. Wow, that guy's like wrapping all the way around the board. So what we're going to do is we're going to take the multimeter and just see if we got any kind of voltage off of it. Anything. So the fan's not important right now. So this will be a good indicator. So there should be something. We are getting 1.929 volts. So what I'm going to do is we're going to be, actually I have to use this. I should have put a test lead in for that, but we're going to make our lives a little bit easier on this. That way I don't have to hold everything down with, we put this guy in ground. Put this guy back on the temp sense. And I'm going to see if the voltage changes with my fingertip warming it up. I mean, the voltage is going up. The temperature is increasing. Now I'll take my fingertip off. It's probably still going to go up. Then it'll start cooling down. Probably should put the fan on it. You know what? That's a good idea. Let's get back into putty. Let's set the fan. Get it going, at least something. Should help cool it down. Oh, you're supposed to be going down, you goofy chip. Okay. So let's cool that puppy down. Okay, why are you climbing and not going down? No, it could be because other things going on, and that pin is actually not defined to be ADC. Oh, got a little hovercraft going on here. Yeah, that little fan's pretty powerful. Yeah, so I think we'll be able to get into it and we'll be able to get into it and do more better testing and troubleshooting once we actually get some code written for it. It just might be because it's kind of a pin that's not doing anything. So it's just giving us a false reading. It's not set up for anything. All right, so one of the last things I want to do is I'm pretty confident and this would have been done anyway. Let's get our little heatsink guy attached to this. You know, that's the way it's supposed to be. Because that is as specified in the bill, in the BOM. Got our little guy, little heatsink attached to our driver. So that is a beauty. And I'm really happy with where we are so far. We've troubleshot and made sure the stepper actually drives. It works, which is one of the core components of this design. One of the things that we absolutely needed to work. And it does. It was just my failed logic. The fan works, which is a good win. So now the biggest thing is, like I said, the temperature sensor and then the inputs. And we will pick that up in the next video because we're pretty much approaching an hour. So yeah, as you can tell with this industry, it takes time. Everything takes time. You're not going to slam all this out. That's why if you've ever, if you've ever hired a company to do this type of work or ever had it quoted, this is why. There's a lot of effort, a lot of work involved that, you don't see. It goes on behind the scenes. And that's unfortunately the way it goes. It can get expensive doing this type of work. It's just because it's time consuming. It really, really sucks down a lot of time. As obviously you can tell. So that's a good thing. I'm closing the session. So I really appreciate you hanging out with us today and sticking with the video series so far. I hope you've at least learned something from it. Possibly that this is too much of a hassle to get into. I mean, that is always a lesson that you could learn, that there's just way too much involved, and that taking the risk of going this far with a project and wanting to take it that far, it's going to be time consuming. It's going to be a road. To do it right, it definitely is going to be a road. So if that's a lesson, something you take away from this video series, it's not something, that's still good. There's nothing wrong with that. Recognizing what you really want to get into, what you're really willing to do is definitely worthwhile. It's always a good lesson. Some people don't learn that. I've known a few people that never learn that lesson, and they end up going broke. They're not really into it. They're not willing to put all the effort into it. So they go broke, or, they have a business that fails, or a business that really doesn't do any good. Doesn't really grow, doesn't go anywhere because their heart's not in it. Because it's very daunting. And yeah, you could pay other people to do this work. I mean, that's what some businesses do. You have a person that has an idea and they just pay other people to do the work for them. I can name a bunch off, at least one off the top of my head where, the person who, basically just bought their way into the business. It's not like they innovated anything. They just bought their way in, and somehow they're portrayed as a genius. But, you could always do that. Buy your way in. I'm just being honest here. Just paying other people to do the work for you, to do all the development for you. That would be a lot more expensive, but, it's still a lesson you can learn, a direction you can go in. But if you're enjoying learning the ins and outs and how difficult and how interesting this can be, definitely please stick around, because we're making some progress. We're making headway, and the first pilot board is so far looking good. A couple more tests to do, and to write and put together to validate the design. And once we're done with that, then we can really start playing with the stuff that could utterly destroy this poor thing, like some of the loading tests, the reverse voltage, and all that stuff. So the stuff that could actually really punish this board and put out of misery. But those are tests that we need to do to push its limits and see what it does. And with those, we'll have some test fixtures to build. And I'll probably definitely have you along for the ride for those, because like for the resistance box, once I know it works, I mean, I'll put together a BOM for it and all the files that we put together in like Fusion, and they'll be up in the project resources. So if you want to build one for yourself, you can. You'll be able to use it in other applications. That'd be pretty cool. And anything else that we build, if it's a Fusion file, a 3D file I create, I'll have the STL as well as the Fusion file available to download for this project, because they're still learning aids. So again, thanks for hanging out with me this evening, and I will catch you in the next video. It should be Wednesday, should be Friday. Take care and have a nice rest of your evening.